Chapter 6, Exponents. Begin by looking at page 2. Alright, in this exercise we are going to evaluate the following exponents. So realize when we write, or when you see this written, it is like saying -1 times 7 squared. The negative sign is outside of the power. It can also be written as a -7 squared, realizing that the power only affects a 7. In this case, this is a -1 times a 49, which gets us a -49. On our calculator, so if we can do -7 squared, realize we get the same value out there. Okay, exponents that have negative values, so like we're seeing here, 5 to the -3, this negative sign means that we could write it as a fraction version of 5 cubed. These two are equivalent. This version just shows it as a non-fractional version. So we could type this in our calculator, 5, and then inside of the parentheses a -3, and realize we get 0.008. This is equivalent to 1 over 125, which is also our 0.008. Number 3, we are squaring the value, so the squared, we could indicate that as 9 over 11 negative times another 9 over 11 negative. We could multiply these two fractions together. Negative times negative gives us a positive. 9 times 9 gets us 81, and 11 times 11 gets us a 121. On our calculator, we could put it in as -9 over 11, and if we insert parentheses and square it, you'll get the same value. Okay, similar to the last problem, this becomes a -1.2 times a -1.2. So we can type in a -1.2, square it, and our value is going to get us to a 1.44. Number 5. So this power, 0 power, an equivalent version of that would be like saying if we had x to the -1 times x to the 1. We could rewrite this as 1 over x times x over 1. Notice this is a fractional version of it, and with them the x's would cancel out, and you can get a 1 over 1, or simply 1. Notation-wise, we could write this as x to the -1 plus 1 in our powers, which becomes x to the 0, which equals 1. So our shortcut on this is anytime we see something to the 0 power, we can assume that it's equal to 1. So we can place our value to the 1. On our calculator, 1.87 to the 0 power, put that in parentheses, and you get 1. Okay, so square roots, this is like writing 196 to the 1/2 power. So the 1/2 is the same as a square root. On our calculator, we can type it in either way. We could do the square root of 196 and get 14. Alternately, we can do 196 to the 1/2 power, and we'd get 14 again. Taking the square root of 2.25, so we'll take square root 2.25, and we get 1.5. Number 8. So this, we have a lot happening here. We could break it down if we wanted to write it in an exponent form. This negative sign is a -1 times our 8 to the 1/3 power. So notice it's a cubed root. On our calculator, we can do -1, and then we can do 8 to the 1/3 power, and we get -2. Number 9, we've got a 4th root power, so this is like 16 over 81 to the 1/4 power. So, parenthesis, we'll do our 16 over 81 to the 1/4 power, and we get 2/3 for our answer. Okay, number 10. We could write this as, well, we could write this as, let's do that. So we could write this as a cubed root of 0.125. Those are equivalent versions. On our calculator, it's easiest to type it in as 0.125 to the 1/3 power. And we get 0.5 for our solution. Okay, so when we are multiplying numbers that have the same base, notice these are the same values, we can add the exponents. So we could write this as 0.5 to the 2 plus 6 power, because we're adding it up. This would get us 0.5 to the 8th power. And we could evaluate that. 0.5 to the 8th power, and we can get a value of 0.00390625. Our simpler answer is 0.8 or 0.5 to the 8th power. Okay, in this problem, we've got a power and a power, and if you have a value to a power, you will multiply those. So we can take that as -3 to the 4th times the 5th. The issue here is we want to evaluate the absolute values first on here. So when we apply the absolute values, our negative sign is going to go away. So we can write this as 3 to the 4th times the 5th, which equals 3 to the 20th power. Number 13. When we write this out, we could write this as a 1 over 4.2. So we can take this value, and since this is negative, we can move it to the denominator position. And it is cubed times 4.2 cubed, and that's over 1. Notice these cancel out, and we just get 1. Numerically, we could write it 4.2 to the negative third power plus third power, or 4.2 to the 0 power, remembering that anything to the 0 power is 1. Number 14, we can apply this cubed power into both of these, so we could write it as 2.5 to the negative 4 over 1 times 1 cubed over 2.5 to the third power. We could reevaluate this as 1 over 2.5 to the fourth power times 1 cubed is just 1 over 2.5 to the third power. And when we combine this, we can get 2.5 to the 4 plus 3, and 1 over that. So 2.5 to the 7th power over 1, or 2.5 to the negative 7th power. We can write, or 15, we can write this as 75 to the 1/2 power. And you can evaluate or get the decimal value from the calculator if you wanted to evaluate that any further. Okay, number 5, or page 5. We can simplify this to write it as 27 over 50 to the 1/2 power. And if we evaluate that on our calculator, so 27 over 50 to the 1/2 power, and we get a value of 0.734846923. This being our more simplified value. Okay, scientific notation. With most scientific notation, we want a number, our decimal point, any leading or trailing valuable numbers, and then times 10 to the power that we've moved it over. So in this case, we're going to write it as 1.296. So notice we have the 1 in the front and the 296 here. And we're going to evaluate how many spaces over we had to move our decimal point to get the factor of 10. So times 10 to the, that's 3, 6, 9, 10, 11, 12, 13. So 10 to the 13th power. Our next number, notice that we'll have a 4 as our main digit, so 4.7 times 10, and we realize we go over 1, 2, 3, 4, 5, 6, 7, 8. So 10 to the negative 8 because we've gone from a bigger number to a smaller number. Engineering notation. With engineering notation, we want the 10, the times 10, into powers of 3, multiples of 3. So in this case, we are going to go 37, because that's our 1, 2 groups of 3, times, we missed our 0.5. 37.5 times 10 to the 369 power. And these factors, or the engineering notation, convert really well to your common units like megawatts, gigawatts, milliamps, millivolts, and so on. Engineering notation for number 20. So groups of 3. There's 1, 2, 3, 1, 2, 3, and then 1, 2, 3. So 261 times 10 to the 369 negative 9 power. Okay. Number 21. We've got 80 squared divided by 250. On our calculator, we can plug this in directly. So 80 squared divided by 250, and we get 25.6. Okay, number 22. We're going to calculate another square root. So we could alternately write this as 4,000 times 14.4 to the 1/2 power. Because it's just a simple square root, we'll use the square root symbol. 4,000 times 14.4, and we'll get a value of 240. Okay, so it wants us to write this one in standard form, basically meaning we want to multiply this out. So if we write it as 3.6 and then times 10 to the third, we can go 1, 2, 3 spots moving the decimal place and get 3,600. On your calculator, we could do 3.6 times 10 to the third power and get the same value. Okay, number 24. We can break this apart into 2 separate pieces. We could do 3.60 divided by 3.20 times 10 to the negative third over 10 to the third. And we could evaluate these separately. We could bring this up. That becomes 3.60 over 3.20 times 10 to the negative third times 10 to the negative third. We'll get 10 to the negative 6 there. We can do 3.60 divided by 3.2. So this would evaluate to 1.125 and then times 10 to the negative 6 for our final value. Alternately, you could type in the full problem. So on the top, we've got 3.6 times 10 to the negative third divided by everything in parentheses in the bottom, 3.2 times 10 to the third. And we get a small decimal value that we'd convert back to our 10 to the negative 6 factor. That is the end of chapter 6.